Okay, so we're going to continue the 6-1 notes for matrices. This is the 6-1 section, multivariable linear systems and row operations. And now we're going to talk about Gauss-Jordan elimination, where we are going to create a matrix. It's an augmented matrix in what's called reduced row echelon form. And so row echelon form was ones on the diagonal and zeros underneath, and then we didn't really worry about the rest. Reduced row echelon form instead is going to look like ones on the diagonal and zeros everywhere else on this part of the augmented matrix, on the X, Y, Z column part. And then the answer part will still have numbers for it. And what that's going to do is, once you've done all the row operations to get yourself to this point, then you're done. Because in this first row, you know exactly what X is, because X is the only thing that you have. In the second row, you know exactly what Y is, because Y is the only thing that you have. And in the last row, you know exactly what Z is. So the disadvantage of this is you have to do more row operations. The advantage is, once you're done with the row operations, you have the answers staring at you. So we're going to do an example of this on the next board. And let's take a look and see. This is our example 2, and we're going to solve by Gauss-Jordan elimination here. I'm just going to abbreviate Gauss-Jordan. Here's the system that we're going to solve. It's X minus 2Y plus Z equals 15, negative 2X minus Y plus 2Z equals negative 1, and negative X plus Y equals negative 9. And you notice there's no Z in that last one, so what I'm going to do is I'm going to use a 0Z placeholder, so plus 0Z, to fill that, kind of like we did in long division, and kind of like you do in a lot of other situations where you don't have that 0, but it helps to make things quite a bit clearer. So the nice part is that we already know how to create the augmented matrix. Let me turn all these minuses to plus, negative, and it's the same thing. It's the X's, the Y's, the Z coefficients, and then the answers, and that'll be our augmented matrix. So that'll be 1, negative 2, 1, 15 is the first equation, negative 2, negative 1, 2, negative 1 is the second equation, and the negative 1, 1, 0, negative 9 is the last equation. And so I'll start a new board, and we can start working row operations from there. So let me rewrite our augmented matrix, our original augmented matrix, and we can start working the row operations from here. It doesn't like me when I try and write 2's for some reason. So here's that original augmented matrix based just on the equations. And then we want a 1 right there, and that's already the case, so I'm okay there. What I'm going to do is I'm going to get it into row echelon form first. So I'm going to concentrate on getting a 0 right there. Okay, I'm going to get rid of that so we can look at it a little bit easier, but that's the goal, is to turn that -2 into a 0. And I'm going to do it the same way. If I make that first row, if I make the first element of the first row a 2, then 2 plus -2 will be 0. So this works the same way. So I'm going to do 2 times row 1 plus row 2, and that will get me a 0 right there, and that's all I really want to do for right now. So remember, I'm going to do this multiplication by 2, but then I'm going to undo it immediately as far as writing the matrices. So I'm not going to write that new matrix, I'm just going to do it and undo it. But then I'm going to do 2 times 1 is 2, 2 plus -2 is 0, 2 times -2 is -4, -4 plus -1 is -5, and 2 times 1 is 2, 2 plus 2 is 4, and then 2 times 15 is 30, 30 plus -1 is 29, and then I'm just going to recopy the third row because I haven't done anything to it yet. When you get real good at these, you can do multiple things with multiple rows at once, but we're not going to do that yet. Okay, so now I've got this new matrix, and let me take this -5 and turn it into a 1. That'll be an easy next step. If I just do -1/5, well, do I want to do that yet? Yeah, I'll do that. -1/5 times row 2. And it's going to get a little messy, but this is how I've been showing you, and it'll turn out just fine. So then we're taking this second row, multiplying it by -1/5, so times 0 is still 0, times -5 is +1, that's what I really wanted, times 4 is -4/5, and times 29 is -29/5, and we'll deal with that later and as we go and stuff like that. That won't hinder us too much. And then -1, 1, 0, -9. So I've got that part. Now let me work on the third row. And it turns out that if I'll try and squeeze this last one in here, if I just do, if you look, if I just do row 1 plus row 3, I'll get a new row 3, okay, with a 0 right there. Then my goal is to get a 0 right there. So first row doesn't change. Second row doesn't change. And then the third row does change. So we're going to do 1 plus -1 is 0. Row 1 plus row 3, remember. And then -2 plus 1 would be negative 1, and then 1 plus 0 would still be 1, and 15 plus negative 9 is like 15 minus 9, which is 6, and I have a new matrix that I'm going to have to copy down here so I can recopy it to the next board a little bit easier, so I don't have to try and remember this. Okay, so let me start a new board here, and I'll put this same matrix up there. So we've got 1, negative 2, 1, and 15. Then we've got 0, 1, negative 4 fifths, and negative 29 fifths, and 0, negative 1, 1, and 6. So that's that much. And then we want this to be another 0, and I'm going to do that by doing row 2 plus row 3. That'll give me, that won't change row 1. That won't change row 2, remember, because I'm going to do and undo immediately. And then, what it is going to do, though, is 0 plus 0 is 0. 1 plus negative 1 is also 0. And then negative 4 fifths plus 1 is negative 4 fifths plus 5 fifths is 1 fifth. And then negative 29 fifths plus 6. 6 in fifths is 30 fifths. That is 30 divided by 5 is 6, right? Yeah. So 6 is 30 over 5. So negative 29 plus 30 is positive 1. So this also is 1 fifth. That's just a coincidence that those two came out the same. And then I want that to be a 1, right? So that is pretty easy to do. I can just multiply row 3 by 5. I can do 5 times row 3, and that'll happen. So now I've got this 0, 1, negative 4 fifths, negative 29 fifths, and 0, 0, because 5 times 0, because we're doing this whole thing times 5, so 5 times 0, 5 times 0, and then 5 times 1 fifth gives me 1, and 5 times 1 fifth again gives me another 1. So now that's row echelon form, but that's not the goal. The goal is reduced row echelon form. So I am done with row 3 as far as that goes. But now what I want to do is I want to do more with this. And the way I'm going to do more with it is I'm going to use what I've got in row 3 to get a 0 in row 2. I'm going to have to copy this down on separate paper again so I can put it on a new board, so bear with me just a moment. And one thing that we already know is we already know what z is. Z equals 1, right? So this tells us then that z equals 1, and if you're doing Gaussian elimination, all you would have to do is go back through. But we're going to do Gauss-Jordan. So here's our new matrix. Again, let me just copy it down here. 0, 1, negative 4 over 5, negative 29 over 5, 0, 0, 1, 1. And so now you need a row operation to turn this into a 0. So that's what we're going to do. And all that that takes is if I take row 3, okay, if I take row 3 and I multiply it by positive 4/5, so positive 4/5 times row 3 plus row 2, that will give me a 0 in that third column, and it won't change anything else because I'm going to do all of this times 4. It'll change the answer, but it won't change any of the other variable parts because I'm going to be doing times 0 and times 0. So my first row doesn't change. My second row will change. My third row doesn't change. But my second row, I'll do times 0 plus 0 is 0, and times 0 plus 1 is still 1. But now 4/5 times 1 is 4/5, and 4/5 plus negative 4/5 is 0. And then 4/5 times 1 is 4/5, plus negative 29/5 is 4 plus negative 29. So let me do this as some side work here. 4/5 plus negative 29/5, which is negative 25/5, which is negative 5. Okay? So now I know another piece to this. Now I know that y equals negative 5. And then finally, I can take this matrix and I can use that to do the elimination on the x's. So you work your way down to row echelon form, and then you work your way back up to reduced row echelon form. So let me start on a new board here and rewrite this one that we're getting pretty close to being done here because we've got the y 0, 1, 0, negative 5. We've got the z 0, 0, 1, 1. So now, if I want to get, let's start with making this one a 0. Okay, let's start with making that one a 0. And the way to do that is to use row 2. And if I do 2 times row 2 plus row 1, then I'll get a new row 1. And that row 1 will be gotten by taking all of this, multiplying by 2. So my bottom rows stay the same because I'm going to do and undo to row 2 again. And then 2 times 0 is still 0. 0 plus 1 is 1, and that's by design. Then 2 times 1 is 2. 2 plus negative 2 is 0, and that's the 0 that I was trying to create. And then 2 times 0 is 0, and 0 plus 1 is 1. And then 2 times negative 5 is negative 10, and negative 10 plus 15 is 5. Okay? And then all I have to do is make this one a 0. So that's my next step, is to make that one a 0, and I'm going to use row 3 to do that. And that'll be real easy if I just do negative times row 3 plus row 1. Then I get that new one. So my bottom 2, again, they're not going to change. I'm going to do and undo to row 3. But then, so I'm taking this bottom row here, and I'm distributing a negative, and then I'm adding together. So we'll do negative times 0 is negative 0, which is the same as 0, plus 1 is still 1. Negative times 0 is 0, 0 plus 0 is 0. And then negative times 1 is negative 1 plus positive 1 is 0, and that's why I did all this. And then negative times 1 is negative 1. Negative 1 plus 5, okay, negative 1 plus 5 is 4. And so now I have created something where I know all the answers, okay? I know that x equals 4, because remember, this is x, y, z. So in this first equation, I've got 1x, 0y, plus 0y, plus 0z equals 4, so it's just x equals 4. On the next one, I've got 0x, I've got 1y, I've got 0z, so I've just got y equals, so y equals negative 5. And then in the last one, I've got 0x, 0y, and then I've got 1z, or just z, equals 1, giving me a three-dimensional point, again, of 4, negative 5, let me write that 5 a little better, negative 5, and 1. And so that's how you do Gauss-Jordan elimination. I hope that helps. I hope you're able to do some stuff with that. I'm going to have an assignment online for you to try on the study guide, and the next time we'll answer some questions. Thank you.